Hello everyone. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture, we will discuss question number 24 and 25 of exercise 5.1. So let's start the solution. What question says? Determine if f defined by f of x equal to x square sine 1 upon x if x is non-zero and if x equal to 0, 0 value is continuous. It means we need to find in its domain, we need to check in its domain the function is continuous or not. Okay, or at which point it is continuous. Yeah, so basically you can see for x when it is non-zero, the function is defined as f of x equal to x square sine 1 upon x. Okay, x square sine 1 upon x we have right now. Okay, and if our x is 0, then f of 0 value is 0. So it implies that the domain of this function is complete R we have. Okay, so what we can do before 0, that means for all non-zero number we can check the what is the function. Okay, and at 0 we can check. Actually this question has two parts. The first part is for non-zero element we can check, and then for zero element we can check separately. So now first of all, if our x is non-zero, then how they define function? Your function is x square sine 1 upon x we have. Okay, now for any non-zero we have function this one. Okay, so here we can explain the things in algebra. How we can explain? Listen, your f is expressed as your, what is your gx? Let gx is x square, h of x is 1 upon x, and gh, and other one you can assume you have a sine of x, t of x you can assume. Okay, so how many functions we have? Three functions we have, and basically the function fx is like that. We have gx into t of 1 upon of x, or we can say t of h of x. Clearly what we have? Clearly for all x at non-zero, gx, hx and tx all are continuous. All are continuous. If they all are continuous, implies that algebra of these functions also continuous. Also continuous. And composition is also continuous. If composition is continuous and the algebra is also continuous, implies that f of x is continuous for all x belongs to r minus 0. This is the one way to prove the first part, a part. Okay, at all non-zero numbers. But we have another way also. Either you can use this one or you can use this one. Other part is arbitrarily we can prove let a belongs to r minus 0. Okay, so for to check at a the function is continuous or not continuous, how we can check? We need to find its LHL. How we can find? Limit x tends to a negative f of x, limit s tends to 0 f of a minus h, limit s tends to f of a minus. How we can find? Because a is a non-zero quantity. A is a listen. A is a non-zero quantity, so a minus h is also non-zero quantity we have, because h is a very infinitesimally small positive number. So by first we can find, that is a minus h whole square sine of 1 upon a minus h we have. Okay, now we can open it. Limit h tends to 0 a square plus h square minus 2ah sine of 1 upon a minus h, and if we apply limit, what we will get? We will get a square sine of 1 upon a. This is your first equation, you can assume. Now we can find RHL. Limit x tends to a positive f of x, limit h tends to 0 f of a plus h. Again, to find the value of a plus h is non-zero, so a plus h is also non-zero quantity. Understand? So here it implies that RHL, your RHL is limit s tends to 0 f of a plus h whole square sine of 1 upon a plus h we have. Okay, and now limit s tends to 0, again we can open a square plus h square plus 2ah, and here we will get sine of 1 upon a plus h. Okay, and if you apply limit, you will get again a square sine 1 upon a. This is your RHL. Okay, assume it is second equation. Now f of a is a square sine 1 upon a, as a is non-zero number. So assume it is third equation. So from first, second and third, LHL equal to RHL equal to f of a. Okay, so if this question came in 2 marks, then you can proceed by a part. If question came in 3 marks, then you need to do this one part, the second part. By the second part you can proceed. Okay, and the function is continuous. F is continuous at a, and observe that a is an arbitrary non-zero real number, so it is true for all, and then this function is continuous for all non-zero real number. Now we need to proceed for those real number, for zero real number. Okay, now listen. Okay, now observe. Now we have B part. At x equal to 0, we need to check the function continuity. And how it defines? F of x, if x is non-zero, x square sine 1 upon x, and if x is 0, then it is 0. So again we need to find LHL. What we need to find? LHL we need to find at 0. So limit x tends to 0 negative, f of x, limit s tends to 0, f of minus h. As h is a positive quantity, so minus h is a negative quantity. It implies minus h is a non-zero quantity. So we can find f of minus h by the first branch, or we can find limit by the first piece. We can say h square sine of minus 1 upon h. So you can observe that limit h tends to 0, h square, negative will come here. Why? Because sine of minus theta is minus sine theta, 1 upon h. You have this thing. Now it will come as negative of 0 into an oscillating number in between minus 1 and 1. Hence limit is 0. So it implies LHL is 0. This is your third equation. Not third equation, this is your fourth equation. How? Listen, everyone here. What you have here, that h square into sine h 1 upon h is there. If you apply limit here, you will get 0. Okay, that's why I wrote here 0. Okay, but here I am saying that an oscillating number between minus 1 and 1. Why I am saying that an oscillating number between minus 1 and 1? Because if you put h tends to 0, h as h limit h tends to 0, then 1 upon h tends to infinity. But sine is a bounded function. You already know that the sine is a bounded function. Its value is in between. See, the graph of the sine is like that or not, like that graph we have. So its value is in between 1 and minus 1. So it means this is a bounded function. So hence 0 into the bounded function will come 0 value, because that value we know that it is in between minus 1 to 1. It is not become an indeterminate form. Okay, but if we have a function like 0 into some infinite value will come, like suppose we have, I'll give you example here. Suppose you have h into you have suppose you have h raised to the power, wait um, any function, yeah, you can take this one, e raised to the power h, e raised to the power 1 upon h, you can take 1 upon h. Okay, and here you have limit s tends to 0. Okay, so you observe that this tends to 0 and this tends to infinity, so it becomes 0 into infinity. And you observe that as h moves towards 0, the 1 upon h moves towards infinity, so is but infinity tends to more infinity. So this is, but this is not a bounded function, this is not a bounded function, so that's why it becomes an indeterminate form, 0 into infinity. Okay, but here it is not in indeterminate form. Why? So because it is a bounded function. Sine is a bounded function. In place of sine, if cos is there, then also we'll get 0. Understand? I hope you understand this thing. Okay, if you have any doubt related to this, you can do comments. I will explain again. Now we can find RHL. How we can find RHL? RHL is, wait, limit x tends to 0 positive, f of x we have, limit s tends to 0, f of h you have, again limit h tends to 0, h square sine 1 upon h you have, and you get 0. 0 into an oscillating number between minus 1 and 1. Hence its value will be 0. And f of 0 is 0. This is your fifth equation. This is your sixth equation. So from fourth, fifth, and sixth, f is continuous at 0. Here you need to write, for all a belongs to R, minus 0, f is continuous at a. So this is the result from your a part, and this is the result from your b part. Okay, and from both the part we can conclude that the function is continuous for all r, at all r. Okay, at all the points of r. Like that you can proceed in this question, you can do this question. Now move on to the next question. What is the next question? Yeah, here we have, wait, okay. Now listen what the question says. Examine the continuity of the function sin x minus cos x. Again we need to say this thing. So here you can use algebra again. Okay, because the domain of this function, like actually the procedure is same as that we did above. Okay, domain of this function is complete R. So for all these point, for at all these point we need to check, at all the real number we need to check this function continuity. Okay, so first of all we will check at non-zero number, because at non-zero it is defined clearly sin x minus cos x. So here we have the first part, for all x belongs to r minus 0, that is x is a non-zero number. If x is a non-zero number, then you can see, observe that here, that what is your f of x? F of x is your sin of x minus cos of x we have. Okay, as sin x is continuous on r minus 0 and cos x is continuous on r minus 0, implies that their algebra, their addition subtraction also continuous on r minus 0, because we can use algebra. Algebra is in our course. Okay, so it implies that f is continuous on r minus 0. I hope you understand this thing. Okay, now the b part is there. In b part we have at x equal to 0 we need to check, at x equal to 0 we need to check that this function is continuous at 0 or not. Okay, so for that again we need to find LHL, limit x tends to 0 negative f of x, limit s tends to 0 f of minus h, limit h tends to 0 f of minus h value is, because h is a positive quantity, so minus h is a negative quantity, minus h is a non-zero number again. So here we can find by the, wait, I'll write it again here, by the first piece we can find its value. So limit h tends to 0, limit h tends to 0 sin of minus h minus cos of minus h. Okay, and what is sin of minus h? Sin of minus h is minus sin h, and cos of, cos of minus h is minus cos h, plus cos h, because minus h will be in fourth quadrant, that's why. So limit h tends to 0 minus sin, minus sin h will come, and here minus cos h is there. If you apply limit we will get minus 1. This is your LHL. Assume it is first equation for this one. Okay, now RHL we can find limit x tends to 0 positive f of x, okay, and limit h tends to 0 f of 0 plus h, again limit h tends to 0, f of h we have. Again we can find by the first piece, limit h tends to 0, sin h minus cos h. If we apply limit, what we will get? Minus 1 will get RHL. Okay, and f of 0 value is, what is f of 0? Minus n. Implies that from first, second and third LHL, wait, LHL equal to RHL equal to function value. Hence the function is continuous at 0. Here you can observe the function is continuous at all the non-zero real number. Here the function is continuous at 0. If we combine both the results, then we observe that the function is continuous at on complete R. And in the question number 24, same thing we have, that function is continuous also on complete R. Okay, you can apply in the first question also algebra of continuity and in composition of continuity, and in the this one question also can apply, because it is very typical to prove for each real number. So we can prove in general, either you can prove in general or you can apply algebra of continuity, because both the things are in your course. Okay, algebra of continuity also there, or in general also in your course. Okay, I hope you understand both the questions. In both the questions, just we need to check on complete R continuity, and they both are piecewise function they define. The first, you can observe here that you have actually this one, and this one is your 0. Okay, and here they define first piece here by x square sine 1 upon x, and at 0 it is 0. Okay, so it is a piecewise function. I hope you understand the continuity of this piecewise function. Okay, you can generalize this question also. How you can generalize? See here, it may possible that examiner will give you f of x equal to x raised to the power, wait, I will give him here, wait, it may possible that examiner may be asked like that this question, f of x equals to x raised to the power 24 sine 1 upon x. Okay, and here 0 if x value non-zero and x value 0. Again within check it the continuity of this function. Okay, so like that we can generalize, maybe any power of x will become maybe any power of x, but they are saying that how we can generalize more, it is f of x equal to the x raised to the power n sine 1 upon x. X is non-zero, n is a positive quantity, n is a positive quantity, yeah, you can say this one, and x at x equal to 0 we have 0. Again this function is also continuous, f is continuous on R. Okay, so I generalize this question also for all n, for all positive integer we have this thing. So I hope you understand this thing. Okay, this question and generalization also. Thank you for watching.